It's not that New York is immediately vulnerable to sea level rise. Seas would have to rise by over 6 meters to put Manhattan underwater. But in a 2-degree warmer world, New York City is far more likely to experience flooding from storm surge. That's because the city is vulnerable to hurricanes. The last big one was in 1938, when the so-called Long Island Express grazed Manhattan, striking 112 kilometers to the northeast. Over 600 people died. Hundreds of houses were washed into the sea. Today, that storm would be ranked as a Category 3. There are many earlier hurricane strikes in New York's history. Jeff Donnelly is a paleotempestologist, a scientist who studies ancient storms. Like climate scientists in Antarctica, he does this by digging down into history and taking core samples. Here, they're mud cores, and Jeff is looking for evidence of storm surge. The surge is like a tsunami, whipped up by high winds and the extremely low pressure in the eye of the hurricane. It's usually the most destructive element of a hurricane strike.
This gives us some sense for how often a place like New York City has been hit by big hurricanes in the past. It's basically like reading a book. We're just going back through time. And so we split these open, and you can see that this is the organic rich sediment that's being deposited day in, day out. Occasionally, though, as we move further down the core, you've got these large sand layers that are deposited. And these sand layers are the result of storm surge overtopping the beach and washing sand into these ponds and marshes. And this very large layer here dates to the 1938 hurricane in New England. These cores here are actually from very near New York City and was likely laid down by the 1821 hurricane in New York City. It's the last time New York City was impacted by an intense hurricane strike. It was probably the 1815 hurricane, probably 1675, 1635, and then prior to that, these are all prior to European settlement of Eastern North America, so they're all undocumented hurricanes that go further back in time. So we know, direct hurricane strikes, intense hurricane strikes in New York are possible. They've occurred many times in the past, and they're going to occur again in the future.
Previously, in any given year, there was a 1 in 100 chance that a devastating 3-metre storm surge would hit. But in a 2-degree warmer world, these odds will change. Leading climate scientist Dr. Cynthia Rosenzweig has done intensive modelling to predict storm surge flooding.
One part of the climate change projections that is virtually certain is that the sea levels will be higher. That provides the base from which coastal flooding occurs.
Even if the storms don't change, having those higher sea levels really allows the flooding to go inland further. That is the #1 vulnerability of lower Manhattan and many low-lying areas in the New York region.
With higher sea levels, storm surges that would have caused minor flooding in the past will become as destructive as the big once-in-a-century storms.
What our modeling shows is that this very intense 1 in 100-year storm could occur once in every 20 years.
In our children's lifetime, it is very likely that this catastrophic storm will occur.
In such a storm, the New York Stock Exchange, Wall Street, and all of lower Manhattan would be inundated. swathes of the outer boroughs, Staten Island, Queens, Brooklyn, and parts of New Jersey would be swamped as well. But there may be a way to prevent this. Douglas Hill is an engineer who's been thinking about how to protect New York. He and his colleagues at the Stony Brook Storm Surge Research Group have a plan.
Well, all of these waters in the inner city here could be protected if 3 storm surge barriers were placed in the waterways around New York. One here at the Narrows, where the Verrazano Bridge is located, one at the upper end of the East River, where it meets Long Island Sound, and one on the other side of Staten Island. These 3 would enclose this area and protect it from being flooded by a storm surge coming in from the ocean or from down from Long Island Sound.
Around the world, similar barriers have already been built. In London, the Thames Barrier, which admittedly spans a smaller width than the Verrazano Narrows, has been operational since 1982.
Judging by what the Thames Barrier cost to build, each of these would cost about 1.6 to 1.8 billion. The 3 of them would cost about $5 billion.
But plans for this kind of protection are barely on the drawing board. Even if they were built, barriers could only shield about half of the New York metropolitan area. But the city is beginning to figure out how to prepare for climate change. In other areas of the US and around the globe, solutions may not be so simple. Louisiana, Texas, North Carolina. Vast stretches of coastal wetlands that would be submerged if sea level rise projections hold. Miami will come under serious threat. Large parts of Florida's Everglades and their unique ecosystem could be lost forever. Some countries already live with the effects of sea level rise. The South Pacific island of Tuvalu already experiences regular flooding. Only a small further rise in sea level could wipe this nation off the map. Egypt's ancient city of Alexandria is under threat, as crumbling seawalls offer little resistance to the rising Mediterranean. Already seawater is pushing into the fertile Nile Delta, ruining wheat and date crops on which people depend. Bangladesh regularly suffers severe flooding and river erosion, and is forecast to be devastated by climate change within 40 years. It's likely that 35 million Bangladeshis will become climate refugees. Famine, disease and political unrest would take hold.
The poorest people in the world are the ones who are going to be the worst sufferers. They're going to face a lot of danger in the nature of coastal flooding, storm surges, cyclones, all of which would have very harmful impacts.
While it's the developing world that will be most severely affected, climate change will have an impact on us all.
It's a myth that people in industrialized countries have so much technology and so much money will just adjust. We are vulnerable. Think about Hurricane Katrina, in which in the richest, most technologically capable country in the world, we basically suffered, as a result of Hurricane Katrina's impact on New Orleans, a complete collapse of civil society that we weren't able to restore for weeks and ultimately for months.
Even if we could find some way to build barriers against all this rising water, there's one effect of climate change that no barrier can resist: drought and the creeping spread of deserts.
I think the world at 2 degrees Celsius or 3.5 degrees Fahrenheit above the temperature of a century ago will clearly be a much warmer world, a wetter world in many parts, but a drier world in others. It's a world where wildfires could well be an almost uncontrollable problem in parts of the world that have already been prone to wildfires.
Nowhere is this threat more obvious than in the US state of California. In June 2008, it declared a statewide drought. Reservoirs were down to half capacity, which led to strict water management and water rationing. Much of California's water comes from the snow and ice in the Sierra Nevada. And this source is in decline. The most startling evidence of this is the melting of the mountain's glaciers. In 1885, the Dana Glacier was 75% larger than it is today. Climatologist Anthony Westerling from the University of California, Merced, has been observing the changes.
One of the reasons the Dana Glacier is so important is as a symbol of what's happening to snow and to ice in the Sierra Nevada and other mountain ranges around the world as a consequence of warmer temperatures. And just as a glacier holds water as ice from year to year, a big part of our water supply is stored as ice in the mountains each year in the snowpack and melts out in the late spring, early summer. We rely on that runoff for feeding our farms and cities.
Global warming has already brought earlier springs to the Sierra Nevada, and that's meant less time for winter snows to fall and build up, resulting in less water for California. Even with a temperature rise of almost a degree, glaciers are shrinking worldwide. As the Earth grows warmer, accelerating glacial melt will pose a grave threat to huge populations. The greatest fears centre on the Himalayas, which feed the Indian subcontinent's great rivers, the Indus and the Ganges.
There would be a very sharp reduction in flow of water in all the rivers that emanate from these large reservoirs of ice on the Himalayan range. Now, if that happens, it's going to affect 500 million people living on the subcontinent and about 250 million people living in China.
With a 2-degree temperature rise, water shortages will affect not only drinking supplies, but agriculture. Dust bowls could replace farmland all over the world. And drought has another devastating consequence: fire. New research reveals that as the world grows warmer, fire seasons are going to get a lot worse. The California wildfires in the summer of 2008 were the worst in recorded history.
This is our nightmare.
I'm just scared. My kids and my grandkids, I'm just scared.
It's just unbelievable what it's like when you see all those flames coming right at you.
There were nearly 10,000 of them, burning over 5,000 square kilometres. 1,500 homes were lost. Some fires were still burning at the end of November. One fire struck here, in the foothills of the Sierra Nevada. But what happened in 2008 was not an isolated event. Anthony Westerling's research has revealed an alarming trend.
There has been a tremendous and dramatic increase in the length of the fire season in the western United States, well over 2 months in duration.
It's not only the US that will suffer more frequent and intense wildfires. It's going to be a major problem for Australia, Russia, South Africa, and the parts of Europe that will be more vulnerable to drought and heat waves. In a 2-degree warmer world, the Sahara will effectively be moving northward.
That's associated with an extension of something called the Hadley cell, which is where air rises on the equator where the heating from the sun's strongest and moves outwards and descends over regions like currently regions like the Sahara